Hello everyone, I'm Professor Harrison and welcome back to our module on regression. Today we're going to cover two tools that make regression a lot more flexible. The first is the dummy variable, which lets us put categories into a regression. The second is interaction terms, which let one variable's effect depend on another. We're following Margot, a graduate student trying to reassemble a story her family buried. Today she's back on a housing dataset, and this time the house splits into two groups that behave differently. She turns to the next problem in her coursework. So far, every explanatory variable that we've covered has been a number. Square footage, a return, a quantity. But a lot of what we actually care about isn't a number. It's a category. Is the house a waterfront home or not? Is the firm in tech or is it in energy? Did a trade happen before a policy change or after it? And the problem is that these are categories, not numbers. So how do we use them in a regression? The tool for that is the dummy variable, which is also called an indicator variable. A dummy variable equals 1 if the observation is in the category, and 0 if it's not. And that's it. You're just turning it into a yes or no number that the regression can actually use. So let's go back to the houses. We'll create a waterfront dummy. It equals 1 if the house is on the water and 0 if it's not. Let's put it in a model alongside square footage. Price equals an intercept plus a coefficient on square footage plus a coefficient on the waterfront dummy. Now let's watch what the dummy does. For a house that's not on the water, the dummy is 0. So that whole term drops out. For a house that is on the water, the dummy is 1. So you add its coefficient on. Say that the coefficient comes out to $100,000. That means that a waterfront home is worth $100,000 more than a home of the same square footage that's sitting off the water. The dummy coefficient is the gap between the category and the group that you left out, holding the other variables constant. That group that you left out has a name. It's called the reference category. Here the reference is non-waterfront homes, and the 100,000 is measured relative to them. Every dummy coefficient is always relative to whatever reference you choose. One common question is why we don't just add a second dummy for non-waterfront houses too, so both groups get their own variable. Here's the problem if you do that. The waterfront dummy and the non-waterfront dummy would always add up to 1 for every single house. The problem with that is that's exactly what the column of 1s in the intercept is already using. You'd have two pieces of the model carrying identical information, and as we saw last time, that makes X transpose X impossible to invert. So you always leave one category out as the reference. People call this the dummy variable trap, and the fix is to simply drop one dummy. So now let's talk about the second tool. Sometimes the effect of one variable depends on another, and a plain dummy can't capture that, because all it does is shift the line up or down by a fixed amount. To let the effect itself change, we need to use what's called an interaction term. An interaction term is a new variable, and you build it by multiplying two existing variables together. Let's go back to the housing example to make this clear. In our original model, we only had the square foot and our indicator for being on the waterfront. What this model assumes is that all houses, regardless of whether they're on the waterfront or not, have their value increased by the same amount for each additional square foot added. But it's possible that square footage on the water might be more valuable. Let's say that for off-the-water homes, square footage is worth $120 a foot. To let that slope change for waterfront homes, we multiply square footage by the waterfront dummy and add that product to the model as its own variable with its own coefficient. Here's how we read it. For a house that's off the water, the dummy is 0. So the interaction term is 0 and the slope on the square footage is just the original $120. For a house on the water, the dummy is 1. So the slope on the square footage becomes the 120 plus the interaction effect. Say that interaction effect is 80. Then on the water, each square foot is worth $200 instead of just the 120. So the interaction coefficient, the 80, is how much steeper the price per square foot is on the water. And that's the whole idea of interaction. The effect of square footage on price depends on whether the house is already on the water. And one variable's effect now depends on the value of another. This also changes what you'd actually do with the model. An appraiser valuing an extra 500 square feet uses $120 a foot if the home is off the water, but they use $200 a square foot if the home is on the water. The interaction term is what tells you which slope to use. Margot closes the problem set. There's an obvious use for this sitting in her own data. There are years when the correspondent of her grandfather's was active versus years when they were quiet, and a dummy would let her flag exactly those periods. And an interaction would let her ask the question of whether her grandfather's whole relationship to the market shifted once those letters started arriving. So that's dummy variables and interaction terms. A dummy variable lets you put a category into a regression by coding it as a 1 or a 0, and its coefficient is the gap between that category and the reference group that you left out. An interaction term is just two variables multiplied together, and it lets the effect of one variable depend on the value of another. Between the two, you can bring most categories into a model, and you let relationships change from one group or one period to the next. That ends up being most of what you need to do to make a regression flexible enough for real data.